Decision trees and random forest. Right? Previously, we have looked in depth at a simple generative classifier, as you see, knife page, right? And a powerful discriminative classifier, which is support vector machine, which we saw yesterday, right? Which we discussed yesterday. Right? Here we'll take a look at motivating another powerful algorithm, a non-parametric model algorithm called random forest. Right? So machine learning algorithms, they're basically, we can call them parametric and non-parametric. Right? Parametrics भनेपछि हामीले जस्तै हैन जुन parameter हुन्छ, it's the linear regression. These are, they are parameters, हैन, coefficients, bias, those are parameters, हैन. So those kind of where the parameters are tuned by the model, हैन. So those are called parametric models, हैन. And there are some models that do not have parameters at all. Parameters नै हुँदैन, right? So this is non-parametric model. So random forest is a non-parametric model because there are no parameters at all. Okay, so random forests are an example of an ensemble. The ensemble, we pronounce it ensemble method, meaning that it relies on aggregating the results of an ensemble of simple estimators. Right? You take given a random forest, as you'll see. Right? We're gonna see in detail what that means. Right? Ensemble means a mix. Right? Ensemble because a mix of different algorithms, right? Different models. है अनि त्यसको चाहिँ एग्रिगेट गर्ने हो कि त्यसलाई चाहिँ ensemble है okay so aggregating results of an ensemble of simple estimators है okay this the somewhat surprising result with such ensemble models that the sum can be greater than the parts. That is, a majority vote among a number of estimators can end up being better than any of the individual estimators doing the voting. Okay, so you could have always clear from that, of course, but as we'll go on, okay, so you'll see what this means. Okay, so let's get started. So let's do the code. Code man. Let's this is the standard input. This standard input value. Okay, so first, before we understand random forest भनेको के हो, हैन? So हामीले त्यो बुझ्नुभन्दा अगाडि हामीलाई के जान्नु जरुरी छ, we need to understand decision trees, because random forest, as it is said above here, is basically ensemble of decision trees, right? Okay, so fill this first understand what decision trees are. Okay, so random forest are an example of an ensemble learner, means it learns from many simple simple models, right? And then those models are all built on decision trees, right? Decision trees, right? So धेरैवटा decision trees को एउटा aggregation गरेर random forestले चाहिँ हामीलाई prediction दिने हो कि. Okay, so for this region, we'll start by discussing what decision trees are. Okay, so what is a decision tree? Okay, decision trees are extremely intuitive ways to classify or label objects. Okay, you simply ask a series of questions designed to zero in on the classification. Okay, for example, if you wanted to build a decision tree to classify an animal you come across while on a hike, you might construct one short. Let's say, so here's my key. So decision tree would basically you go on asking questions. Right? So first thing, okay. So here we have an example of, so you see an animal, an unknown animal, the animal which you do not know what it is, right? So you are on a hike and you come across this animal, right? So this toma, right? So maybe, okay, so here, just an example, right? So the question might be, how big is the animal? Okay, so if it's greater than 1 meter, we go, and there are other series of questions. Right? If it's less than one meter, okay, so, and then you go this way. Right? Okay, this is the first level one. Okay, a second level now. So now, depending on the answer to this question, you either go I mean, another question is posed. Or question also. Okay? So, for example, if the animal is greater than 1 meter, right? Bigger than 1 meter, right? Now you go over here. Does the animal have horns? Horns, right? Yes. Then you go here. Are the horns longer than 10 centimeters? Right? No. Is the animal wearing a collar? Right? Okay, and so on. So does the animal have 2 legs? Okay, yes or no questions, right? Right? Yes, no. Binary decision. Right? So it's something like a decision tree. So it's a decision tree basically. It's a binary, right? Binary tree. Right? So we can have as many levels as you want, right? When ultimately you decide, okay, this is the animal. You can go on and on and on, right? So okay, so it's good. There can be multiple. So there's no limit to how many levels you can have, right? जति पनि लेभलमा हामी जान सकिन्छ है. अन्तिममा यो लिफ भन्छ है, लास्टमा जुन आउँछ त्यसलाई लिफ भनिन्छ. त्यो लिफ चाहिँ के हुन्छ, लिभ्सहरू के हुन्छ जस्तै अल्टिमेटली ओके यहाँ चाहिँ मेबी अ फक्स है, मेबी अ डियर है, मेबी another one might be. So यसरी लिफमा पुग्दाखेरि now you ultimately arrive at that, what that animal is. Okay, so ठिक छ. Does it make sense? हामीले जुन भनिरहेछौँ, is it making sense to you? ठिक छ, बुझिरहनु भएको छ कि छैन? Yeah, okay, all right. One second.
सर यो सबै इफ स्टेटमेन्ट नै लाउँदै गर्ने हो?
Yeah, if भन्दा पनि if जस्तै भयो. If statement लाउने होइन, because यो त machine learning ले गर्छ हैन, यो त machine will learn that हैन. So यसमा चाहिँ के भन्दाखेरि अब यो एक्जाम्पलमा यसलाई if we want यसलाई चाहिँ manually code गर्ने भने yes we need to use some kind of if else हैन. If यो यता जाऊ else यता जाऊ हैन. Okay, so but actually machine learning ले त के गर्छ भन्दाखेरि machine learning को केसमा चाहिँ अब यो चाहिँ के भन्छ, यो क्वेशन्स जस्तै यहाँ गरिरहेछ नि है, त्यस्तो यो चाहिँ machine learning is यो machine learning भन्दा अगाडि rule based system थियो हैन. So before machine learning है, AI के हुन्थ्यो, AI was rule based, means the programmer used to code, right? And they had to hand code right? Hand code the rules. The machine learning आएपछि like के change भयो भन्दाखेरि the machine could figure out the rules by itself from the data, right? Okay, so त्यसले गर्दाखेरि if else statement भन्दाखेरि yes, non-machine learning group खाली यतिलाई मात्रै हेर्ने हो भने yes we can implement this as a if else statement हैन. तर machine learning मा त हामी if else युज गर्दैनौँ हैन. Okay, machine learning मा it has to figure out है, यसले आफै figure out गर्नुपर्छ हैन. From the data it has to figure out, and you'll see how it does that हैन. Okay, so okay, now so basically यहाँसम्म यो okay जति मैले describe गरेँ त्यो कुराहरू is it, so यो clear हुँदै जान्छ, don't worry है यो कुराहरू. Okay, let's not jump हैन, jump नगरौँ. So but मैले जुन भनिरहेको छु just त्यति कुराहरू त बुझिराख्नु भएको छ नि हैन. यो कुरा सबै क्लियर हुन्छ once we finish this है. So सबै कुरा क्लियर हुन्छ, don't worry है. यसको we are building है, बिस्तारै we are building up on हैन, building up. Okay, all right, so now let's see. Okay, the binary splitting है, the binary splitting हैन, हरेक स्टेजमा हेर्नुस्, there's a binary splitting, binary splitting छ है. अहिले चाहिँ यति machine learning सँग नजोड्नुस् अहिले है, यति सम्झिनुस् कि what is binary decision tree भने के हो है, that's all है, that's all you अहिले वरि गर्नुपर्ने त्यति मात्रै हो कि. So let's not machine learning मा अझै गएको छैन हामी है, we're just learning what is a decision tree right? What is a decision tree? That's all we are concerned about. So decision tree is just like this, where you have, there are a series of questions asked at every level, right? Okay, and then you take one of the paths, okay, one path out of these two, right? Okay, all right. So decision trees, okay. So now it's extremely efficient, In a well-constructed tree, each question will cut the number of options by approximately half. See, understand? Just say, so you have a bunch of these animals. Ultimately, you get to some animal, right? So yes, 1, 2, 3, 4, 5, 6, 7, 8. Out animal, right? Okay. So when you see maybe dog wala, say fox wala, say elephant wala, whatever, right? This is how many. The total number of elements animals 1, 2, 3, 4, 5, 6, 7, 8. So now first level may, first level may. So you eliminate half of them. You see, it's greater than 1 meter. Gone. It's eliminated. The option is gone. Right? So zero in animal, this is zero in, right? You get there faster because every time the second level second level, okay. Now okay, first level, it has any you say now this is out of question. You get a pretty good go. Okay, half family खोज्नु पर्यो अब हाफमा खोज्नु पर्यो है आठवटा मध्ये चारवटामा खोज्नु पर्यो भनेपछि अब यसले चाहिँ फेरि यो चारवटा मध्ये अब दुईटा मात्रै अप्सनमा पुग्यो है यो सेकेन्ड लेभल किनभने यो पनि गयो हामी यतातिर आयो भने यो गयो यतातिर गयो भने यता यो गयो हैन ओके अनि यो यसमा अब चाहिँ now you have to decide between these two, right? So you get to this एकदम फास्ट पुग्छ कि है एक्ज्याक्टली कुन हो भनेर सो त्यहाँ एकदमै फास्ट पुग्छ हरेक लेभलमा चाहिँ के हुन्छ त्यो options are half of the options are eliminated. Okay, makes sense? बुझिराख्नु भएको छ?
Yes, sir.
Okay, so तपाईँले machine learning मा अझै नजाउनुहोस् है. It's just simply what is a decision tree? Okay, that's it. Tree किन भन्ने हो भन्दा something like upside down tree हैन यसको यो हैन उल्टो tree. So right, ultra trees. So that's why these are called, in computer science we call these kind of things trees, right? Okay. All right. So this trick, of course, comes in deciding which questions to ask at a each step. Right? In machine learning implementation decision trees, the questions generally take the form of axis-aligned splits in the data. That is, each node in the tree splits the data into two groups using a cutoff value within one of the features. Hey, but now you know what a decision tree is. A decision tree will happen. Now, our next okay, let's create a decision tree. Hey, let's create a decision tree. Okay, so here we'll create some of these data. Hey, your data created assembly. So here we have say 4 classes. Right? So we're trying to we have to classify this four classes. red this call it blue, right? This is light blue, whatever. Okay, dark blue, light blue, and then so I don't know what this color, yellow. Let's call it yellow. Right? Okay, so I mean greenish, sorry, greenish. So these 4, right, we want to. So this is our raw data. This is our data that we have created, right? It's probably your data, right? Okay, now let's do this. Okay? A simple decision tree built on this data will iteratively split the data along one or other axis according to some quantitative criterion, and at each level, assign the level of the new region according to a majority vote of points within it. Right? The figure presents visualization of the 4 levels. Okay. अब यसमा हेर्नुस् है जस्तै फर्स्ट लेभल जस्तै अब यसमा जुन अब जस्तै हाम्रो यहाँ फर्स्ट लेभल अफ क्वेशन्स दियो नि है यस हैन सो यस्तै हामीले के गर्छौँ भन्दा फर्स्ट लेभलमा अब यो एक्सिसमा स्प्लिट गर्यो उसले है यो y एक्सिस है y मा स्प्लिट गर्दाखेरि उसले यसरी गर्छ कि ओके उसले सो is this point yellow or not yellow? Right? That could be one. Right? Yellow or not yellow? Yellow is not yellow. Right? So yellow or not yellow. Junma, yellow is your body sunny. So first level of splitting. First split. जस्तै यो यहाँनिर फर्स्ट स्प्लिट भएको छ यहाँ त यो स्प्लिटिङ भयो नि त है स्प्लिट हुँदै गएको छ नि त हैन सो सिमिलरली यसमा चाहिँ यो फर्स्ट स्प्लिट है फर्स्ट स्प्लिट येलो अर नट है इज द पोइन्ट येलो यस हैन अर नट येलो है त्यो भन्दै जाँदाखेरि अनि त्यसबाट चाहिँ है अनि धेरै येलो कता छ धेरै यतातिर छ हैन भनेपछि त्यो उले चाहिँ ठ्याक्क यो अनि यो लाइन तानिन्छ जहाँनिर चाहिँ है धेरै येलो जरो हुन्छ है अनि त्यो चाहिँ यो एउटा फर्स्ट लेभल अफ स्प्लिट भयो है अनि सेकेन्ड लेभल अफ स्प्लिट चाहिँ अब यो चाहिँ अब चाहिँ चेन्ज भन्दा किनभने यसमा येलो भन्दा अरू केही पनि छैन नि भनेपछि अब त स्प्लिट गर्न मिल्दैन है यसमा त स्प्लिट गर्न मिल्दैन किन भन्दाखेरि देयर इज नो अदर कलर सो हेर्नुहोस् त सबै अब त्यसपछि हरेक लेभलमा नथिङ हेज चेन्ज है सेम यो स्प्लिटमा केही पनि भएको छैन बिकज देयर इज जस्ट येलो नथिङ एल्स जस्ट येलो हैन स्प्लिट गर्न मिलेन नि त अर्को कलर भयो पो त हैन त्यहाँ स्प्लिट गर्न मिल्छ न यसमा चाहिँ के हुन सक्छ भन्दाखेरि मेबी ओके यसलाई ग्रीन भनौँ है ग्रीन अर नट ग्रीन है ग्रीन अर नट ग्रीन गर्दै गयो हैन अनि जतातिर बढी ग्रीन छ अनि ठ्याक्क त्यो पर्ने गरी त्यसले चाहिँ यो डिसिजन यो बाउन्ड्री है यो बाउन्ड्री तानिदिन्छ है ओके यो चाहिँ सेकेन्ड लेभलमा डेफ 2 भनेपछि यो डेफ 2 है डेफ 1 डेफ 2 है डेफ 2 मा त्यो भयो है डेफ 2 अब डेफ 3 मा के हुन सक्छ भन्दाखेरि मेबी यु क्यान डु अब यसमध्येबाट हैन यो डार्क ब्लू अर लाइट ब्लू यसलाई के भन्ने आई डोन्ट नो है लाइट ब्लू नै भनौँ अहिले है डार्क ब्लू अर लाइट ब्लू हैन त्यसमा पनि हैन डार्क इज दिस डार्क ब्लू अर नट भनौँ न है सो त्यसरी फेरि स्प्लिट हैन अनि त्यसरी अनि देयर सो मेनी लेभल्स स्प्लिट हियर है सो हरेकमा चाहिँ के भन्छ स्प्लिट हुँदै जान्छ है ओके एन्ड यु क्यान देयर इज नो लिमिट टु हाउ फार यु क्यान गो है ओके अलराइट अनि त्यसको एउटा प्रब्लम आउँछ विल टक अबाउट दैट इन अ मोमेन्ट है त ओके So notice that after the first split, every point in the upper branch remains unchanged, means everything's yellow, right? So there's no need to further subdivide this branch. Right? You're saying about हरेक level ma, I mean, split garni जरुरत छैन, right? Okay, except for nodes that contain all of one color, right? जबसम्म त्यो हरेक त्यो split मा एउटा मात्रै color अथवा majority of a color आउँदैन, right? It goes on. And splitting, right? Okay. So this process of fitting a decision tree out data can be done in scikit-learn. So the good thing is we don't have to do it manually, right? The good news is scikit-learn has this covered. Okay. So now we can import decision tree classifier, right? And you'll automatically go right? Automatically. And you manually go to the right? Automatically here. Let's do that. Hey, so decision tree classifier. So as I said, okay, so rule we'll have to figure out garcha. Right? Jस्तै यो त्यसमा यो रुलहरु हामीले फिगर रुलहरु हामीले राख्दियो भने त मसिन लर्निङ भएन नि हैन दैट इज नट एआई दैट इज नट मसिन लर्निङ त्यो चाहिँ अब जुन अहिलेको मसिन लर्निङ आउनु भन्दा अगाडिको प्री मसिन लर्निङ भनौं न त्यतिबेला रुल बेस्ड सिस्टम्सहरु हुन्थ्यो बिजनेसमा हैन बिजनेस सिस्टम्स एन्टरप्राइज सिस्टम्सहरु एआई भनेर रुल बेस्ड सिस्टम है सो अब चाहिँ because we don't encode the rules in our systems in the systems the system or the software the system the algorithm figures out the rules from the data okay that is what machine learning is machine learning भनेको के भन्दाखेरि it figures out the rule from the data right data बाट rules figure out गर्छ है okay all right so now okay let's do this so we import this and then we instantiate okay step number 2 step number 3 we fit x and y hey हाम्रो data fit गर्यो x or y hey and then it gives us this you fit y service now tree okay now tree is a fitted model hey tree is the fitted model okay now let's see hey so well okay so now here's a this code will produce the visualization right visualization this code so which is this visualization right here hey so हामीले के गरौँ हाम्रो xy जुन data so this data right here hey your data right we run it through a decision tree classifier a decision tree classifier and this is what we get hey So their whole कति लेभलसम्म जाने it will decide है हामीले के पनि गर्नु पर्दैन हामीले simply मोडल लियो इन्स्टेन्शिएट गर्यो फिट गर्दियो है it will decide कहाँनिर गएर रोक्ने किनभने it can go on and on and on and on है त्यो कति लेभल जाने भन्ने कुरा त्यसको लिमिटिङ हुन्छ जबसम्म हरेक त्यो स्प्लिटमा एउटा मात्रै कलर आउँदैन है है normally it will go on forever until that point right so okay त्यसको आफ्नै problem so we'll talk about that right so but here what do you think यसको कस्तो छ is it okay so has it done a good job कस्तो छ I mean overall I mean it's not bad right? Basically it's not bad but we can improve on it right so it's not the best right? It's not the best but your decision tree this is one decision tree right one decision tree and then okay so split ends here all of them are red so I mean overall not a bad job right not a bad job यो जुन हैन यो रिजन्सले यो पत्ता लागेको छ हैन so okay not bad जस्तै यसमा जस्तै problematic कहाँनिर हुन्छ जस्तै how about this this is strip okay this is problematic है यस्तो strips-हरु छ नि यस्तो है so I mean, that can be problematic right so that is not the true actually हाम्रो actual distribution मा त यस्तो हैन यस्तो त हुँदैन है okay यति स्ट्रिपमा एउटा अर्को स्ट्रिपमा यता एउटा यता यति स्ट्रिपमा अर्को त्यस्तो हुँदैन हैन so yeah then yes of course we can improve on it we will improve on it actually right so but as a rudimentary and you're first level okay one decision tree right not bad okay all right so now if you're running okay so let's see let's do interactively right? So let me I think I've already run this let's see if I can do one okay so let's see your first level China this is the first level right first level of split right and if we do 5 levels of split like 5 levels basic books right okay all right so notice that as the depth increases we tend to get very strange safe classification regions like this one you understand yes the split of course I know this is not meant to be like this in the real data but of course it's the distribution हुँदैन हैन यतिमा एउटा मैले अघि एक्सप्लेन गरिसके नि हैन सो यस्तो त हुँदैन है यस्तो हैन यस्तो प्याचेजहरु त हुँदैन नि है so I mean so that is problematic है okay so it is clear that okay यसको मतलब के भयो भन्दाखेरि अब जस्तै हामी level 5 मा पुग्दाखेरि नै हाम्रो के भयो भन्दाखेरि now it's trying to fit this small this this kind of यो डेटा अलिकति यहाँ भित्र गएको छैन त्यो भनेको त एरर मार्जिन हो नि त एरर मार्जिन नोइज हैन सो इट्स ट्राइङ टु फिट दैट नोइज है जस्तो हामीले लिनियर रिग्रेसन केसमा हेर्यौ नि हैन सो ओभरफिट हुँदा के हो इट्स ट्राइङ टु फिट द नोइज है त्यो सानो सानो जुन त्यो भेरिएसन्सहरु छ त्यसलाई पनि इट्स ट्राइङ टु ट्र्याक दैट हैन इट्स ट्राइङ टु ट्र्याक दैट स्मल भेरिएसन्स इन द डेटा the small variation it's coming from that spurious signal so the machine learning model should not pick up those spurious signals right so that's what it's doing the strip server it's overfitting already right तपाईको level 5 मा पुग्ने even level 5 मा पुग्दा साथ even level 5 भन्दा धेरै त होइन नि so level 5 मा पुग्ने हैन even level 5 मै के भयो भन्दाखेरि it has overfitted already. Hey, level 5 may overfit. That's what it says here. That is the decision tree, even at only 5 levels deep, is clearly overfitting our data. Hey, how do you know it's overfitting? Because you're getting these strips as a section on their own. Hey, okay, as their regions on their own. Okay, which is overfitting. Hey, so now the problem with decision tree is that they overfit too quickly. Right? They overfit too quickly. And then there's no way when to stop त्यो हैन त्यसको त्यो कहाँ स्टप गर्ने भन्ने कुरा त्यो हुनै छैन के है just freely छोड्दिने हो हैन I mean it stops at some point and where it tries to हरेक रिजनमा एउटा मात्रै कलर आउने गरी अथवा एउटा मात्रै क्लास आउने गरी उले चाहिँ गर्दै जाँदै त्यसै गर्दाखेरि ओभरफिट भएर you get these strange results and strange regions okay So which is not good, right? It's not good. Okay, so decision trees and overfitting. Okay, let's see. Let's look at that. Eh? So such overfitting turns out to be a general property of decision trees. Okay, general property. Decision trees, of course, they will overfit. Okay? It is very easy to go too deep in the tree and thus to fit details of the particular data rather than the overall properties of the tree. Generalization. Machine learning is about generalized. But it's for generalizing. It's trying to be specific to those, small variations. Okay, so so that is the problem. Okay, another way to see this overfitting is to look at model strain and different subset of data. Okay, for example, let's say estimators. Hey, so now, okay, uh, uh, these two data, your data, so they're coming from the same distribution. Okay, so so two different trees, each and half of the original data. See, it's the same data, same data. It's the exact same distribution, same data. We pick half of the data. It's my half. It's 100.7. It's my randomly 50 points select गरिन्छ है अनि बाँकी रहेको पोइन्ट्सहरु यता है यो दुईटा जोडेर फुल डेटा सेट फुल डेटा चाहिँ यो दुईटा जोड्यो भने we get full data set है त्यसमध्ये हामी यसमा त्यो डेटालाई 50-50 गरौँ न है 50 एक्जाम्पलको लागि सो 50 पोइन्ट्स यहाँ र बाँकी रहेको 50 पोइन्ट्स यहाँ गरे भने यसरी रन गर्दाखेरि सी we get two different regions है हामीले जब decision tree classifier रन गर्छौं है अब कुनलाई मान्ने है ओके जस्तै SVM को केसमा त्यस्तो थिएन है SVM को केसमा as long as your the support vectors are not changed है त्यहाँ भित्र कोही पनि छिरेन भने चाहिँ no matter how much you know what your data is how many points you have the size of your data है you still get the same model same trained model है तर यो केसमा यो पाएन यसमा चाहिँ अब डेटा पछि फरक हुन्छ है अब यो हुन त यो दुवै एउटै डिस्ट्रिब्युसनमा आएको भनेपछि we should expect the same regions है same classes same same distant boundaries हैन because they are coming from the same distribution so that is the expectation तर त्यो भएन किन भन्दाखेरि see half of the data मा यस्तो खालको छ यता half of the data मा यस्तो छ means it is problematic कुनै एउटा definitive भएन के त्यहाँ है okay concrete भएन है so you सबै okay we'll take care of all of these problems right so it is clear that in some places the two trees produce consistent results they यहाँ consistent छ है अब यहाँ हेर्नुस् अब यसैमा अब यो रिजनमा यो हेर्नुस् त so it's different यहाँ चाहिँ 1 2 3 तीनटा छ यसमा दुईटा छ and then clearly they're very different जस्तै यो चाहिँ see अब यहाँनेर यो र यो हेर्नुस् त कति डिफरेन्ट छ यो र यो there's a lot of difference यो र यो चाहिँ ठिक छ फेरि है so consistent छैन के all right so the key observation is that the inconsistencies tend to happen when the classification less certain जहाँनेर less certainty हुन्छ त्यहाँनेर चाहिँ जस्तै यहाँनेर यो less certain छ नि यहाँ त clear cut छ okay that's fine हैन तर जहाँनेर uncertainty छ you get these inconsistencies है okay now let's do this अब हामी के गरौँ भन्दाखेरि okay that's fine so so how about this okay so there's okay so this one actually this was discovered by a retired professor from Caltech California Institute of Technology. Caltech is one of the world's famous university for engineering Caltech professor he had retired already and then he came up with this algorithm after his retirement right this is very interesting so okay so all right so let's see how about this you do this okay we get these two right so if we combine these two and average them maybe we can get better we could get a better classifier if we combine these two just the data combined right maybe we'll get a better result right okay so that's the thought that this professor had okay whoever came up with this is support vector machine company this is interesting so he was a Russian physicist so usko jun ideas 40 years पछि I think 25 or 30 or 40 years पछि light mag nobody cared about that at the time right but somehow this scientific describers are this one, you see. All right, engineering, breakthrough zero. Okay, anyway, so here, look at this. Hey, say a random state, randomly, say 100. Let's see, it's the answer, right? 0, random. It's the same distribution, but we're generating data randomly, so we get different, different trees. Okay. All right, so okay, just as using information from two trees improves our results, we might expect that using information from many trees will improve our results further. Okay, so यसको मतलब के भन्दाखेरि अब यसरी यो दुईटामा हामीले स्प्लिट गरेर यो दुईटालाई एभरेज गर्ने हो भने we get better result, right? So okay, if you experimentally do it, okay, so you'll get better results. त्यसै गरी how about not just why limit at 2? Why not 3? Why not 4? Why not 100? Why not 200? Right? Let's run many of these decision trees. Right? Okay, and then average them. Let's see how it works. Right? Okay, that's the idea. The main idea thing. Right? So that's why it's called ensemble. Ensemble, a lot of these models, different models. Right? And this like saying Utah model must be combined. Okay, that is called ensemble. Okay, all right, so now so what do we do? Hey, so now that's random forest. Okay, random forest, we take many of these decision trees, same data, right? And then we randomly pick these data, right? And then run hundreds of them, hundreds of decision trees, right? And then randomly select a sample serve. त्यही डेटाबाट हामीले randomly data select गर्ने, हैन, decision tree run गरिदियो. फेरि अर्को sample decision tree, अर्को sample decision tree, अर्को sample decision tree, and then we once त्यो सबैले आफ्नो दिन्छ नि, त्यो region दिन्छ, हैन, classification दिन्छ, अनि we average them together, right? And then we get the final model, which is random forest. Random forest, random forest is the ensemble of estimators. Okay, right? So do you intuitively बुझ्नु भयो यो कुरा? So far मैले भनिरहेको कुरा बुझिरहनु भएको छ? बुझिएन? हेलो, बुझ्नु गाह्रो भयो या तपाईहरुलाई? Are you there? Hello. Okay, बुझ्नु गाह्रो त भएको छैन, मतलब intuitively बुझ्दैन. So I mean, I don't expect you to fully know, fully understand एकैचोटीमा. I don't know. Okay, but at least what I'm trying to say, are you keeping track, or are you following what I'm saying? No?
Yes, sir. Will I follow the sir?
Okay, all right. So of course, yes, but of course, affiliate the minute the gardening person. You need to read, right? You need to try. You need to, delve into, other resources as well. Hey, class that's not going to happen. Hey, त्यो चाहिँ कसैले मलाई पनि हुँदैन, मैले पनि एउटा नयाँ कुनै कुरा हैन सिकिरहेको छु भने मैले एउटा क्लासमा एकचोटी भनेको भरमा मैले पनि बुझ्दिनँ है. I get the idea, but fully बुझ्दिनँ. Okay, I have to go back, I need to think about it, I need to try. Okay, right? So it's natural, don't worry. All right, anyway, so ensemble of estimators, random forest, right? Then this notion that multiple overfitting estimators can be combined can be combined, right? So so this is the idea. The idea is that multiple overfitting estimators can be combined to reduce the effect of this overfitting, and is what underlies an ensemble method called bagging. Okay, bagging. So this is called bagging because हामीले धेरैवटा estimators, धेरै decision trees run गर्छौं, and we let them overfit. We let them overfit. हामीले कुनै त्यसलाई रोक्दैन है. हरेक डिसिजन ट्रिज ऱ्यान्डमली हामी स्याम्पल गर्छौँ है अनि त्यसपछि के गर्छौँ भन्दाखेरि त्यसमा डिसिजन ट्री रन गरिदियो है अनि त्यसपछि के हुन्छ भन्दाखेरि okay, we have less than 1 minute, so I'll just stop here and then please join back in and then